All right. Okay. Department of Energy Fundamental Handbook. Fundamental Handbook Instrumentation and Control, Volume 1 of 2, U.S. Department of Energy, Washington, D.C. 20585. Approved for public release distribution unlimited. FSC 691. All right. All right, Department of Energy Fundamental Handbook of the Instrumentation and Control, Module 1, Temperature Detectors. List of figures, list of reference object with resistant temperature detectors, temperature, RTD, construction summary, thermocouple, construction, thermocouple operation summary, functional use of the temperature detectors, functional temperature detection, detector problems, environmental concern summary, temperature detection circuitry, bridge circuit construction, bridge circuit operation, temperature detection, circuit temperature compensation summary. There's figures, and we'll start reading. Alright, your resistant temperature detectors. Temperature, with the hotness, with the coldness, with the piece of the plastic, wood, metal, with the other material, with the unbound, with the molecular activity of material, with the kinetic energy made with the activity of the atoms, make up with the molecules of any material, with those temperatures measured with the kinetic energy of material in question, whether you want to know the temperature surrounding air, the water cooling of the car's engine, for the component of the nuclear facility you have seen, with the sum of the means to the measure for the kinetic energy of the material, most temperature measuring the device to do with the energy material system of the monitoring rate over the low and the kinetic energy to derive the normal household thermometer is one example. Mercury and other liquid of the bulb of the thermometer expand with the kinetic energy rate by observing how far the liquid rises from the tube, that you can tell with the temperature measured object. But if we cover the temperature is one of the most important parameters of the material making instruments have they develop and measure one type of detector, you the resistant temperature detector, the RTD. The resistant temperature detector is used with the Department of Energy for nuclear facilities measure for the temperature of the process material being monitored. The resistant temperature detector incorporates the pure metal with a certain alloy with a decree for the resistant temperature and decree for the conversion. Conversely, decree for the resistant with the temperature for the decree for the resistant temperature detector acts somewhat like an electrical transducer, converts the change of the temperature for the volt signal by the measurement of the resistant metal to the best suit for the resistant temperature detector sensors are pure with the uniformity, quality, stability, with the given the range for the temperature, able to give the reproducible resistant temperature reading. The only few metals have the property for the necessary for use of the resistant temperature detector elements. Resistant temperature detector elements that are normally constructed with the platinum, copper, nickel, with the minerals over the tube of the resistant temperature detector applicated with the air linear resistant temperature characteristics is shown in Figure 1 of the high efficiency coefficient resistant ability with the and repeated temperature cycles. Coefficient resistance of the chain of the resistance of the pure degree of the chain of the temperature usually expressed with the percent of the per degree of the temperature of material used must be capable of being drawn into fine wire so that eliminating can be constructed. Figure 1 shows the electrical resistant temperature curve. The temperature of the resistant temperature detector element is 0 degrees Celsius. Resistant temperature of the element at ohms, nickel, copper, and platinum. Resistant temperature detector is usually long and spring-like wire with the surround with the insulator and clap lives of the sheath of the metal. Figure 2 show the internal combustion resistant temperature detector show the Bailey Control Company in conal sheath, the porcelain insulator, the platinum wires, and aluminum powder. Internal construction of the typical resistant temperature detector. Particular design of the platinum element with the porcelain for the insulator prevented the short circuit between the wire and the metal sheath with the inconal with the nickel iron coronium alloys normally used with the manufacturer resistant temperature detector sheath because of the inherent with the corrosion resistant place. When placed in liquid or gas medium, the inconal sheath with quickly relief of the temperature of the medium, the chain of the temperature will cover the platinum wire heat or cold, resulting in proper proportional change of the resistance. Change in resistance then measured by the precision resistance measuring device and then calibrated to give the proper temperature reading of the device normally by circuit, which will be covered in detail later in this section. Our Figure 3 shows the resistant temperature detector protective valve and the terminal head of the well with the resistant temperature detector form and the damage of the gas and liquid being measured. Protecting well normally U with the stainless steel, carbon steel, inconel, cast iron, U with the temperature is 1100 degrees Celsius. Summary resistant temperature detector are summarized below. The resistant temperature detector summary. The resistant temperature detector varies directly with the temperature. As the temperature increases, the resistance increases. As temperature decreases, the resistance decreases. The resistant temperature detector constructed with fine pure metallic spring-like wire surrounded by insulator and encapsulated in metal sheet. The change in the temperature they will couple the resistant temperature detector heat or cool and producing proportional change in resistance chain of the resistance is measured by a precision device calibrated to give it the proper temperature reading. Alright, thermocoupler. Thermocoupler constructed. The thermocoupler is constructed two dissimilar metal wires joined with, at one end. When one end of each of the wire is connected to the measuring instrument, the thermocoupler becomes sensitive to the highly accurate measuring device. The thermocoupler is constructed with several different combinations of the material. Their performance for the thermocoupler material is generally determined by the material within the platform. The most important factor to be considered when selecting the pair of the materials are in the thermoelectric difference between the two materials. The significant distance between the two materials will result with better with the thermocouple performance. Figure 4 illustrates the characteristics of the commonly used materials when used in platinum. With platinum, show that the dE over dAf in the microvolts in degrees in Celsius thermatic power platinum. Constant aluminum, iron, copper, chromium, PT90 are resistant 10 pound. Other materials may be used with addition shown figure 4, but for example, the chromium constant is excellent temperature for the 2000 degrees Fahrenheit. Nickel, ammonium, sometimes replaced with the chromium, allium. Tungsten rhenium is used at the temperature of 5,000 degrees. Some of the combinations specialized application: chromium, white gold, molybdenum, tungsten, and tungsten in iridium, rhodium. Type 5 show the internal construction of the typical thermal lead with the lead of the thermocouple concave with the ridge of the metal sheet with the measuring of the junction of the normally formed at the bottom of the thermocoupling housing. Magnesium oxide surrounded with the thermocouple wire with the prevent vibration from the could damage of the fine wires efficient and enhance the heat transfer between the measured junction and the measured medium surrounding the thermocoupler. Figure 5 shows the internal construction of the typical thermocoupler. The Bailey control company with the inconel sheet with the thermocoupler wires, the magnesium oxide. Couplers will electronic current flow with the attached circuit with the subject with the thermocouplers will couple the electrical current to flow with the attached circuit with the subject with the chain with the temperature amount of the current will then produce the independent of the temperature with the difference between the measurement reference junction characteristics of the two metals used with the character of the attached in the circle. The figure 6 shows illustrates a simple thermatic circuit show the heat source measuring junction hot with a voltmeter with the reference junction with the cold dissimilar metal wires. Heat the measured junction of the thermocouple produces the voltage with the grade of the voltage graph with the reference junction with the difference between the two voltages proportional to the difference of the temperature can be measured with the voltmeter for each of the operator. The U of the sum of the voltmeters are separated with the read out directly with the temperature through the use of electronic circuitry. Other applications provide with the millivolt readout. In order to convert with the millivolt readout and corresponding table to corresponding temperature, you must refer to the table to select the one shown in figure 7. Each of the tables can obtain with the thermocouple manufacturer the list of the specific temperature corresponding with the temperature with the millivolt readings. Summary: thermocouplers are summarized below. Thermocouplers summarized. The thermocoupler is connected to two dissimilar wires joined at one end with the enclosed in the metal sheet, with the other end with each of the wires connected with the meter or measuring circuit with the heating of the measure. Junction of the thermocouple produce the voltage with the greater of the voltage of the curve of the reference junction. The difference between the two voltages is proportional to the difference in the temperature when they measure with the voltmeter. Alright, function of the temperature detectors. Although the temperature of the bench would vary slightly depending on the detail of the facility design of the temperature of the detector, you will provide with three basic functions: indication, alarm, and the control. With the temperature monitored may normally display with the central locations of the control room may have the audible visual alarm that associated with them and specified with the preset limits for the exceeded. These temperatures may have the control function associated with them, such as the equipment that serve as opposite support with a given temperature condition, so that the protective action occurs. Detector problems. In event of the key with the temperature sensing of the instrument with it becoming the operative, the supplement the alternative method may be used. Some of the application utilize the installed spare temperature detectors, dual element resistant temperature detector. The dual element resistant temperature detectors are two sensing elements which only normally connected. If operating element becomes faulty, the second element may be used to provide with the temperature indication. If it's installed with the spare, but it's not utilized with a contact pyrometer, portable thermocoupler may be used to obtain temperature reading whether those pieces of the system are accessible. If it malfunctions with the circuit with the detector, there is still function with it may be possible to obtain the temperature back in any external bridge circuit with the detector. Resistant readings that may be taken with the corresponding temperature obtained with the detector calibration curves. Environmental concerns. Ambient temperature variation will affect the accuracy of the reliable temperature detecting instrument range variation. Ambient temperature can directly affect the resistance of the component of the bridge circuit with the resistance of the reference junction and thermocouple addition with the ambient temperature variation can affect with the calibration of electric and electronic equipment. These affect with the temperature variation reduce the design of the circuitry maintained with the temperature detection instrument with the proper environment. Presence of humidity will affect with the most electronic equipment extensively with the electronic equipment. High humidity, the moisture of the cloud with the equipment, the moisture can cause the short circuit with the ground with corrosion, which in turn may damage the component. The effect is due to the humidity controlled by the maintaining equipment with the proper environment. Summary: detector use. Detector using some of the temperature detectors are used for indication, alarm, and control functions. Temperature detector became inoperative as the air detector may be used if installed with a contact pyrometer may be installed. Environmental concern: ambient temperature and humidity. Temperature detection circuitry, bridge circuit construction. The figure show the bridge circuit with the three known resistors: resistor 1, resistor 2, resistor 3 variable, the known with the variable resistor RX. RT resistant temperature detector source voltage within sensitive to the ammeter. All right, as you notice that the ammeter is inside the resistor 4 resistor winding or bridge circuit. The resistor 1 and 2, the ratio arm of the bridge, for the ratio of the two variable resistance for the current flow of the ammeter. Resistor 3, the variable resistor known with the standard arm through is adjusted the match for the unknown resistor, sensing an animator with a visually display with the current through the flowing through the bridge circuit. The angle with the circuit is shown by the resistor 3 adjusted the ammeter of the reads for the zero current. The resistance in both of the arms of the bridge circuit is the same. The equation 1 shows the relationship of the resistance between the two arms of the bridge. Resistor 1 over resistor 3 is equal to resistor 2 over resistor X. Since the value of the resistor 1, 2, and 3 are known values, the only unknown resistor X is the value of resistor X can calculate a bridge during the ammeter zero current conditioning, knowing that the resistant value provide the baseline with the calibration instrument attached to the bridge circuit, known as resistor X, is given in the equation 1, 2. Resistor X is minus resistor 2 times resistor 3 over resistor 1. Bridge circuit operation. Bridge operates the placing of the resistor X with the circuit shown with the figure 8 with adjusting the resistor 3 with also current flow with the arm of the bridge circuit with the addition exhibit the current no current flow through the ammeter of the bridge with the step of the B bound with the bridge is bound with the current flow through each of the arm with exactly proportional with each of the resistor 1 and equal to resistor 2. Most of the time bridge for the construction with the resistor 1 were equal to resistor 2 with the K for the bridge bound with the resistor X with the same with the resistor 3 or resistor X is equal to resistor 3 with the bound with the resistor 3 with the equal the unknown resistor even with the voltage over the unstable and non-accurately. Well, the typical Wheatstone bridge with the shovel the dial will vary the resistance on bridge balance with the dial can be refined with the value of the resistor 3 bridge circuit can be used with the measure for the resistance tenths or even hundreds of the percent accuracy when using the measure temperature for the sum of the Wheatstone bridge with the precision resistors are accurate up to 1/10 of the Fahrenheit. The two type of the bridge circuit the unbalanced and balanced are utilized with the resistant thermometric temperature of the detection system. Detection circuit, the unbalanced bridge circuit, the figure 9 is the millivoltmeter with calibrated with the temperature corresponding with the resistant temperature temperature detector resistance. The figure 9 shows the unbalanced circuitry with the resistance thermometer, unknown resistance on the resistor bridge, going from the battery X and Y. Go on a circuit between the moving coil, the millivolt and lead resistor. The battery is connected with the two opposite with the bridge circuit for the multi-view for the connect with the two remaining points. With the rheostat of the regulates the bridge circuit with the regulated current with the divide within the brain for the fixed resistor for the brain for the resistor 1 with the brains for the resistor temperature detector range resistor 2 with the electrical pass resistor for the resistant temperature detector chain with the voltage with the points of the X and Y millivolter detect with the chain with the voltage with the copper with the unequal division with the current with the two brain for the meter with the calibrated unit the temperature because the only change resistance value with the resistor temperature detector the balanced bridge circuit with the galvanometer to keep the resistant temperature detector resistant with a fixed resistor and figure galvanometer, even the pointer of the defect with the each other side with the zero. The resistance of the arm is not equal to the resistance of the slide wire is usually adjusted on the galvanometer, indicating zero. The value of the slide resistance is then you determine the temperature of the system being used. Figure 10 show the balance bridge circuit, show the battery rheostat resistant bulbs to the slider, the slide wire, resistance 1, 2, 3, and 4, fixed resistors, galvanometer, and then the center. The slide resistor yield the balance of the arm bridge, but the circuit is also balanced around with the value of the slide wire resistance, such that no current flow through the galvanometer with the temperature change with a new value, therefore the slider must be moved to a new position balancing the circuit. Temperature detection circuit, the figure 11 of the block diagram. Typical temperature of the detection circuit, the representative of the balance bridge temperature of the detection circuit that has been modified to eliminate or show the mechanical linkage between the scale and the balance motor. Balance motor, the bridge circuit of KTC, the original resistant temperature detector. Bridge circuit KT CKT to the DC AC converter, the amplifier. Block consider the temperature of the detector, the measure for the temperature of the detector, filled with the resistance of the bridge net, with the bridge net, with a convert with the resistance with the DC voltage signal with the electronic instrument with the developed with the DC resistor pentameter with the bridge with the converter with the AC volt with the AC voltage with the amplifier with higher than usual voltage with the E with the drive with the bidirectional motor. The bidirectional motor position is the slider on the slide wire balance circuit resisting the resistant temperature detector becomes the only open either the unbalanced with the unbalanced or with either unbalanced or balanced bridge circle. The resistance will be finite and the meter will indicate the very high temperature. It becomes short. The resistance will vary, but the meter will indicate very low temperatures. Calibration of circuit precision resisting resistor known value with the substitute with the resistance to be a bulb is shown in figure 12. The 12 show the resistant thermometer circuit between the precision resistor in play for the resistant bulb millivolter resistant bulb with the resistor adjusted rheostat and the resistors. The battery voltage adjusted with the varying volt resistor B with the until the meter indication correct with the known with the resistance temperature compensation. Cover the change the aim and the temp of the resistant thermometer. The circuitry must be compensated with the resistor of the energy with the measuring circuit with the select with the resistance of the remain with the constant the range of the temperature expect with the temperature with the compensation accomplished with throughout the design of the electrical circuitry compensates the ambient chain with the equipment and combinate with the possible resistance with the detector lead with the U with the chain with the ambient temp with the compensate with the current chain with the 3 to 4 resistant temperature detector circuit that you in the way with the same amount of the lead wire with its both branch of the bridge circle the end chain with the resistance will be felt when the both branch of the negating effect of the change of the temperatures. Alright, some of the temperature detection circuit operation summarized below. The basic circuit operation summary. The basic bridge circuit operation consists of the two known resistors, resistor 1 and 2, that use the rotating adjustable is known with the resistance 1 known variable, the resistor 3 that is used to match for the unknown variable, resistor 1 unknown variable, the resistor X that use to measure the temperature, sensing and the meter indicate the current through flow of the bridge circuit. Bridge circuit is considered bound with the sensing ammeter that reads zero. The circuit of the basic temperature instrument is combined with the resistant temperature detector measuring over the temperature bridge network with converting resistance with the voltage of DC to AC voltage converter to supply with the amplifier with the AC signal with the amplifier, the AC signal amplifier to amplify the AC signal usable level of the balance motoring mechanical linkage of the assemble the balance and circuit the resistance. An open circuit with the temperature instrument is indicated by a very high temperature or circuit with the temperature of the instrument is indicated with a very low temperature. The temperature instrument of aim the temperature compensation is accomplished by measuring circuit resistor selection, electrical circuit design, and 3 to 4 wire resistant temperature detector circuits. Our Department of Energy fundamental with a handbook instrumental control module 2 pressure detectors.